This right here is the equation for the general theory of relativity. It's possibly one of the most important equations ever made. But what's interesting about it is it did not start out as one equation. It actually started out as 10 different equations that were all combined together using one principle, the cosmological principle.
But what even is the cosmological principle?
Well, to explain, here are some Legos. Now let's just imagine that each of these bricks represents a galaxy of around 300,000 to 3,000 light years across.
And now let's take all the bricks and place them in a basket and then randomly shake them up.
Alright, then we're going to take the basket and divide it in half. And then we're going to take the two divided halves and weigh each of them separately. As you can see, that is 344. And then we're going to do the same thing for the other half. As you can see, 344.
So now you can see both halves have about the same mass. But what's interesting is both halves are almost completely different. I mean, look at over here. You have smaller, thinner pieces connected together. Well, over here you have a bunch of separate blue pieces that are pretty large. But in the end, both halves have the same mass.
But how does this experiment relate to Einstein and the universe in general? Well, when Einstein got stuck with those 10 equations, as mentioned before, he decided to use the cosmological principle because, as shown with the Legos, when we zoom out from a wider perspective, things like mass become irrelevant, but also speed of light at the universal scale. So on the scale of like 100 million light years, stuff like speed, mass, and light become irrelevant. It just allowed Einstein to cut out tons of variables and make the equation we all know and love, the theory of general relativity.